Now, first thing you need to learn about surds is how you add surds. So for question 2, part 1, just imagine that was 2x, 6x, and 3x. What would the answer be? 5x, wouldn't it? Surds are no different. So what do you think the answer is to the first part? The first answer is 5 roots 2. The next trick is, well, I've taught my second years how to do this without the calculator, so I'd hope I could teach you guys how to do it without the calculator as well. Now, the lazy way to do this is 2 root 2. You just put root 18 into your calculator, and it will do it for you. 3 root 2. Now, 2 root 2 plus 3 root 2? 5 root 2. All day long, yeah? Now, what you guys need to know, because you guys are going to have to do more difficult questions eventually, so you need to know how you turn root 18 into 3 root 2. Anybody know? Exactly. Use these numbers here. These numbers are perfect squares. Okay? And any trick you're going to use goes through these numbers. Now, you see root 18, you go, okay, which one of these numbers goes into it? You say root 9. Now, there's the multiplication effect of surds, which means root 2 by root 9 is in fact root 18. Is that okay with you guys? So, that will mean 3 root 2. Everybody cool with that? Now, what doesn't happen with surds, however, is like this. If I had root 2 plus root 3, the answer is not root 5. Square roots are as different as x and y. You can't add x and y together, can you? No. So what we just learned there, you're not allowed to add surds if they're different numbers. Does that make sense? You can only add them if they're the same number. So root 2 plus root 2 would be the same as x plus x, which would be 2 root 2 or 2x. Is that alright? Now, really quickly, will you guys do 2 part 6? Like super quick. No calculators if you can help it. So, without using the calculator, I see root 20 and root 80. And I'm thinking of 2 perfect squares that divide into them. I'm going to go for root 4 for that. I could also do root 4 for that one, but I can think of a larger one. What's a larger one? 16 would be better. They both have to end up as root 5s anyway. So 2 root 5 and 4 root 5. Everybody cool with that? So 7 root 5 plus 2 times 2 root 5 minus 4 root 5. And the answer is, everybody, 7 root 5. Yes?
It's 2 root 20. Where is it?
Oh no, it just did root 20 on its own. And I turned root 20 on its own into 2 root 5. And then I multiplied the 2 root 5 by 2 to get 4 root 5. And then 4 root 5 take away another 4 root 5. 0. Alright, that's fair enough. Good question. Now, let's move on. I need to move fast, lads. Sorry. Now, this one I have I've shown once again the second year's just a little trick here. And here's the trick I showed them. You don't want, it says, in the following quotients means a fraction, rationalize the denominator. Rationalize means I want a rational number for the denominator. I do not want an irrational number. Does everybody know what an irrational number is again? An irrational number is a number that when you put into your calculator, it cannot be displayed as a fraction, as one whole number divided by another whole number. So you see that it won't display it as a fraction. Do you notice the decimals? There's no pattern, is there? No pattern in the decimals. This means irrational number all day long. Rationalize the denominator means turn the denominator into a rational number. So here's my trick. I just multiply top and bottom by the irrational parts. So what do I do, top and bottom? Multiply top and bottom by root 50. Then what happens? I get 20 root 50 divided by 50. Right? Cancel the, so it's going to be 2 over 5. Now what is root 50? It's root 25 by root 2, which is 5 root 2. What's 2 multiplied by 5 root 2 divided by 5? 10 root 2 divided by 5, which is just 2 root 2. Aren't sure? Just log into the calculator. Once again, you guys should be able to do it without the calculator. If you can't do it without the calculator, it's going to cost you later on. Okay? Should not have to do it without the calculator. Alright, you're on your own for that later on. 2 and 3. Now, next thing. Anybody? Root 4 multiplied by root 4. Root 16, which is 4. Let's take out the middleman. Root Kenny by root Kenny, or root Ken by root Ken. Ken, isn't it? Or technically root Ken squared. But that just turns into Ken, doesn't it? Now, to do these questions, I'll do the more difficult one up to 2. That's a lot, to be honest. Alright, A times A. A times minus 2 root B. Yeah, just slot in the A beside it. Minus 2A root B. 2 root B times A. 2A root B. Happy days, they cancel. And last one, what's 2 root B multiplied by another 2 root B? 2 by 2? 4, yeah, it's a minus because one one's a minus, one one's a plus. Root B by root B? B. The answer is A squared minus 4B. We good? You're going to try and multiply out some of the part 4s as well. Now, alright. Oh, keep forgetting. Oh, it's on time today. Brilliant. Now, next thing is, once again, it says rationalizing the denominator. What does that mean? Yeah. Now, you guys saw me do a trick earlier where if I had 5 over root 20, I'd multiply top and bottom by root 20. That only works when it's just a square root on the bottom. Only works when the square root on the bottom is on its own. Okay? Won't work for this one. You can test it out if you want. So, if I was doing, let's say, question 2, now 12 over 3 root 2. If I just did this, if I multiply top and bottom by root 2, or minus root 2, it won't work. Here's what you have to do for question 5, and here's what you do for every part of question 5. You use what's called a conjugate, okay? And what you do is, if it's a minus root 2, change it to a top and bottom. And what this creates, what you want to create on the bottom is what? Every single time on the bottom, what do you want to create? You want to create the difference of 2 squares every time. Everybody get that? Every time you want the difference of 2 squares. When you do that, it just the denominator sorts itself out. Why am I allowed to multiply the top and bottom by the same amount? What's the deal with that? Why am I allowed to do that? If I have 5 over 2, and I multiply the top and the bottom by 4, for example, what's the answer? 20 over 8. 20 over 8 is still the same fraction as 5 over 2. When you multiply top and bottom by the same amount, it doesn't affect the value of the fraction. Everybody cool with that? So you multiply this out, you get 36 plus 12 root 2. And then on the bottom, you're going to get 9 plus 3 root 2 minus 3 root 2. And that's going to happen every time. Every single time, that's going to work. And then what do we get then? 36 plus 12 over root 2 divided by 7. Now, I might be lucky even that in the calculator, once again, you're not allowed to say you used your calculator. That's not what we're looking for. Same answer, right? Great. Yes?
Like part